Okay, this video is going to be part 3 of 3, dealing with special segments in circles. And this one is going to deal with tangents and secants intersecting. We had chords intersecting, secants intersecting, and now we're going to look at, we've already looked at tangents a while back. Now we're looking at tangents and secants intersecting. So when you have a tangent and a secant intersecting, we may have something like this. Remember that a tangent touches. It's barely going to brush by and touch. The tangent never enters the circle, and the secant slices. And just like with your secants, they're going to represent them as segments whenever dealing with these intersections. So this is what you're most likely going to see. So here we don't have 4 different parts like we did with the chords intersecting and secants intersecting. Now we only have 3 different parts. So here we're going to go ahead and name the tangent and the secant. For the tangent, we'll go ahead and, like I did with the other video that I had for the secants, we'll go ahead and use this tangent and secant segment part right here. Your tangent's going to be segment KL. It's going to start and then stop right at that circle. The secant will be the one that slices through the circle. This will be segment KI. The formula for when a tangent and a secant intersect, what we're going to do is we're still going to use the outside times total like we did with the secant, but for the tangent, what we're going to do is we're going to take that tangent and we're going to square it. This will be set equal to the secant's outside times total. So we have 2 problems. Let's go ahead and take a look at the first one here. We're going to look at tangent equals, so we find the tangent line right here, and this will be tangent squared, so we're going to take 15 squared. We will set this equal to the secant's outside of 9 times the total, and I said this with the secant intersection. This is, you have to add them. Every single secant with these intersections, you're going to have to add 2 parts together. And this is adding, not multiplying. This is not 9x, ladies and gentlemen. This is x plus 9. Please be careful with that. So when we solve, 15 squared will give us 225. And with the other side here, we're going to have to distribute 9 times x, 9x. 9 times 9, positive 9, positive 81. Go ahead and pause the video. We have 2 more steps. Solve for x on your own. With this problem, make sure that we got 16. If we did not, check that work. Subtract the 81 and divide by 9. The next one, I do encourage you to set it up on your own, pausing and set up on your own. The solving will be a little bit different than the previous problem. Again, looking at the first part of the formula, tangent squared. So the tangent is over here at segment JI. This is going to be an x squared. That's how it's going to differ from what we had up here. We didn't have an x squared, we squared a number. This is what we're solving. We will set this equal to outside 4 outside of the secant times total. Again, cannot stress enough, you have to add the parts for that second section of the secant. 4 plus 5, we have 4 times 9. When we solve, we will have x squared equals 9 times 4 is 36. Just like with any problem where we had x squared or Pythagorean theorem, c squared, we have to take the square root. So to solve for, to get rid of the radical of square, we're going to take the square root of both sides, canceling the exponent. The square root of 36, this is a perfect square, which means we will get a whole number, and this will be 6. Okay, so that is not only the end of secant and tangent intersection, but for the students at Katy High School, this is the end of 10.7 notes. Special segments in circles.